Hello and welcome back to Introduction to Physics. Today I'd like to look at interference, diffraction, and polarization lab. So if you'll go to Canvas and then modules and then labs and then Introduction to Physics Unit 3 labs on mechanical and electromagnetic waves. And then when you open up that document, if you go down to the bottom and click on Lab 18, which is interference, diffraction, and polarization. Okay, let's take a look at the pre-lab questions. So what's the purpose of the lab? So if you will just go down into the lab itself, you'll find what the purpose is and then just copy and paste that. Then safety instructions. Now this one there are some safety instructions because we're going to be using a laser and you do not want to shine the laser into your eye. If you are doing this one at home, you could go to Walmart and get a laser pointer for about $5 and then you can do any of the experiments that I'm talking about today with that. Then you're going to, what is the concept of interference? What does it mean for two waves to interfere with each other? Okay, question number 4 is, what is diffraction? So what's the concept of diffraction? And then question number 5, is light from the sun polarized? So you'll need to probably look that one up on the internet to find the answer to that one. Okay, now let's go down to the actual lab itself. Now some of these experiments I'm going to do for you, and then other experiments you're going to do, and then other experiments you're going to be looking them up on Google and then recording your results. Okay, so first I want you to go down to part 1 of the experiment is on interference. And the first one is called gap interference. And for this one, you're going to need a laser, so a laser pointer, and you're going to need a Newton's rings apparatus, which I don't expect you to have. But this is it. So this is a Newton's rings apparatus. You can see that it has two glass plates. So the plate here on the bottom is completely flat. The plate that's on top of it is curving like this. Okay, and then the two of them are on top of each other, and then light is going to go through the top one, and it's going to be reflected off of the bottom surface of the top piece of glass, but then other light is going to go through the top piece of glass and is going to be reflected off of the top surface of the bottom piece of glass. And then when those two light waves come together in your eye, because the light is going to bounce off of each time it's going to bounce off a surface and then go into your eye. So that by the time that the light goes into your eye, it could either be constructive or destructively interfered with. So go to the internet on Google and type in Newton's rings apparatus or Newton's rings, and then go to images to see what the light should look like. Okay, now I'm going to try to hold this up to the light so that you can see it, but let's see, right down there at the bottom. Okay, so down at the bottom of the screen you should see a series of circles within circles. Okay, that's the phenomenon that we're looking for on this. Circles within circles. Now, in your lecture notes on interference and diffraction, I show you a picture of Newton's rings and then how the light is bouncing off the inner and outer surfaces of them and then going into your eye. So I encourage you to look at those notes, then find images on the internet of how these Newton's rings work, and then I want you to describe here how they work in the lab itself. Okay, now that was white light on Newton's rings apparatus. Now if you look on the internet, you will also find examples of like red light on Newton's rings and then blue light on Newton's rings. So if you look at the images, you'll see that. And so it's easier to explain with one color shining on Newton's rings. And then once you understand that, then you should be able to understand how it works for multiple colors, because that's what white light is. So white light is going to be a combination of all the different colors. So imagine if instead of just using one red laser pointer shining on the Newton's rings, instead you had like 5 or 6 different laser pointers shining on it, each of a different color. Well, that's what white light would be. Okay, so I want you to be able to try to explain what is it that is causing the interference effects with the Newton's rings. So that was part A of your lab. Okay, now we're going to go down to part B, which you are going to do at home. So you're going to get some soap and you're going to make soap bubbles, and then you're going to be looking for a rainbow of colors in the soap bubble, and then you're going to explain why. So what is causing that rainbow of colors? You've got white light that is shining down on the soap bubble, and then the light is being reflected into your eye. So how can that white light be turned into a rainbow of colors? And it is not going to be refraction. It's not a refraction effect. So it's not like it's a prism. So go to your notes and find out, there should be a picture in your notes of a soap bubble and how it's actually an interference effect. And then you might also want to go to Google and type in interference effects on soap bubbles and read about it. But again, you're going to describe what happens and explain why in terms of interference. Okay, so I'm going to stop here, and then when we come back, we're going to look at two-slit interference.